So let's start the second part of the notes, where now we will still use the general form of writing the arithmetic sequence, but most often we're going to be using these two equations here, where if we're given two pieces of information, we'll use a specific equation. When we might go back and use the other equation is if we're maybe giving some different information and we have to go and find A1. They give us something else that will help us find A1, but we've got to find it. So you'll see that here in a minute. But basically, we're going to talk about arithmetic series, and the difference is a sequence is the list of numbers. The series is the sum of that list of numbers. So sometimes we want to know what the sum of a list of numbers in a sequence would be, and if you are given the first and last terms, a1 and a sub 1 and a sub n, then you'll use this equation. We only need to know a sub 1 and a sub n. If you have a sub 1 and d, then we will use this equation. Usually they'll say, if you have a sub 1 and d, find s of 12. And so you know n as well because they're defining it and what they're asking you for. Okay, so we're going to have to choose which one to use first. Then we're going to work with this. Then we're going to come back and talk about this sigma notation, but it's basically just a shorthand of writing. If we have n and if we have k, which is going to tell you your final term. So we'll get to this here in a minute, but this basically gives you this information, but it looks different. So if we start with example A here, example 4, part A, we want to know the sum of the series for the first 100 odd natural numbers. So that would be 1, 3, 5, 7, and so on, all the way up to a sub n when we have 100 of them. We don't necessarily have to know what that is. So we'll start, we're given a sub 1, and we know that they're odd. So we know the change in between these is going to be 2. So we're going to use this equation to start with. So, alright, so we know a sub 1 is going to be 1, because that is the first odd natural number. We know that the common difference to go from one to another is 2, and we know n because we know we need 100 numbers. So those are the pieces that we need to plug things in, and we're just going to replace them in this equation. Alright, so this is S of 100. S sub 100 is the number of terms that we have is 100. The 2 stays there. This 2 stays here. A sub 1, our first term, is 1, so 2 times 1. N is 100, and D is 2. So all we really have to do here is fill in this information. Oops, excuse me, I meant to copy this. Okay, so let's change this out. This just becomes 50. This is just 2 times 1 is 2. 100 minus 1, well, that's 99. Alright, so that would be the same as 50 times 2 plus 198, or 50 times 200, which is 10,000. So your final answer here, the sum of the first 100 odd natural numbers is 10,000. That's your final answer. So that one's nice and straightforward once we determine what they've given us. Sometimes they'll just give you the sequence. So what do we know here? We clearly know that a sub 1 is negative 18. Do we know our D? the common difference between these terms? Yes, we can figure that out because we always take the second term. It's important to always take the second term. But negative 15 minus negative 18, that means these are increasing by 3. So D is 3. What else do we know? Our sequence isn't ended with an ellipse. We have a number here, so we know that A sub n is 66. So we know A sub 1, we know D, we know A sub n. We don't necessarily know how many numbers we have unless we go through and write them all in. So if you know your common difference D, you're more likely than not to be using, let's see, what did I do? Yeah, so we need n. And when we're done here, actually, we know A sub 1, we know D, and we know A sub n. So you can use either equation when you're finished. So this one is easier when we have this information. We did not have A sub n on here, so that's why we had to use this specific equation. But either way, what do we not know here? We don't know n, so we've got to find it. So that means that we have to go all the way back to our standard form and see if we can figure out what n is. So we're going to use our standard form. Okay, so what do we know? We know A sub n, that's 66. A sub 1 is negative 18. We don't know n. We do know D is 3. So now the only variable missing is the n, and we can solve for that. So this becomes 66 equals negative 18 plus 3n minus 3. So we'll put the negative 18 and the minus 3 together. And we get 66 equals negative 21 plus 3n. We will move the negative 21 to the other side and get that that is 87 equals 3n. We will divide by 3 to get that n equals 29. So now we know n. And we can go back up here. Let's just use the other equation because we know n, we know A sub 1, we know A sub n, and this one is just a little bit easier to use. So we're going to use this equation and fill in what we know. The sum will be n is 29. Oops, we're looking for s sub 29. Our initial A was negative 18 and we ended with 66. So negative 18 plus 66 over 2, and we're just going to do this math. So this will be 29 times 66 minus 18. So that's 66, 56, 48 over 2. I'll just write it that way. No, there we go. And that equals 29 times 24. And our final answer here, what do we get when we multiply that, is 696. So our sum will be 696. So we have to sometimes send this, let's see, we have to sometimes find what we don't know, and when you do that, you're going to go back to your equation that we used in the first part of the notes today. Alright, let's look at C. Okay, so here what do we know? We know that A sub 1 is negative 16, D is 6, and N is 24. So we know A sub 1 and we know D. We know a sub 1 and we know d, so we're going to use this equation. Okay, so let's fill in what we know. We know that n is 24. We know that n is 24. We know a sub 1, that is, oops, there we go, negative 16. Be really careful not to lose those negative signs. This is 24, and d is 6. Okay, so all we have to do is finish out this math. So 24 over 2 is 12. That'll be 12 times 2 times negative 16 is negative 32, plus 24 minus 1 is 23 times 6. Let's just show it that way. So now we're down to 12 times negative 32 plus 138. And you could show another step here, but this is fairly simple enough. Your final answer here will be 1,272. That's the sum of the sequence described here with 24 terms. Alright, so those hopefully are pretty clear. Find the first 3 terms of each arithmetic series. Okay. What's hard about these is they're giving you the sum of the series, and you have to detract from that the information that we need. We have a sub 1, we have a sub n. To find the first 3 terms, we need, for this, you need to have at least a sub 1 and then the common difference d. So what are we missing? We're missing that common difference. So for this one, whoops. Okay. This one we know a sub 1 and a sub n. We're given s of n. So we need to use the equation with those pieces of information, a sub 1 and a sub n. So we're using this one. Alright, whoops, almost back there. Here we go. And we'll fill in what we know. We don't know n. Then we'll have to use n to find d. So we don't know n yet, but we do know that s of n is 13. Whoops. Oh man. Okay. $13.68. Okay, we don't know n. We know a sub 1 and a sub n. It's not going to let me do that, but a sub 1 is 48. A sub n is 180. And we can solve for n. So this is equal to, it's disagreeing with me here, hang on, equals, there we go, n times 180 and 40 is 228 divided by 2, and that is n times 114. So really what we have to do is divide 1368 by 114 to get n. So when we do that, we get that n is 12. Okay, now we have a sub 1, we have n, and we have that a sub n is 180. So we've got to go back to our general equation. Where did I use it? I filled it in. Okay, we're going to go back to our general equation here because we know a sub n, and we can use this equation to help us find d. Okay, because let's look at this equation here. So it gives us a sub n, which we know that's 180. We know a sub 1, we know n, we're going to look for d. Okay, so this here, a sub n is 180. A sub 1 is 48. We know now that n is 12, and we can solve for d. So this will be 48 plus 11D. So we'll have to subtract subtract 48 and then divide by 11. So 180 minus 48 is maybe 140, 132 equals 11D. So that means that D equals, what is that, 13? Oh, that's also 12. 11 times 11, 121, yes, 12. Okay. We've probably forgotten by now, but the directions say, what are the first three terms? So now you have that D equals 12, and we have that A sub 1 equals 48. So we can find our terms. So we get 48 plus 12, which is 60, and we get 60 plus 12, which is 72. That is, after all that work, your final answer. Okay, so we've got one more like that. Here we're given n, a sub n, and s sub n. What's missing? We don't know something very important. We need a sub 1. So we have to find that. So we have a sub n, s sub n. Let's go back up here and decide which equation to use. Here. We don't have D. We don't have a sub 1 in any case. So what can we do? If we fill in what we know, they did give us S of n. We don't know D. So if we use this one, we don't know A sub 1 and we don't know D. So there's two unknowns here. If we use this one, there's only one unknown, A sub 1, and we can fill that in. So you've got to think about, what am I going to choose so there's only one thing missing? Okay, so we can take this and fill in what we know and solve for A sub 1. Then we'll also have to find D. So n is 28. Actually, n is 28, but we know that S of n is 20. Darn it. 29. It really doesn't like that. I don't know why it's doing that. Okay, we're just going to do this. 2982 equals, n is 28. We know that. We don't know a sub 1, so we have to leave that alone. We do know that a sub n is 228, and the 2 is a constant. So now we have to take this and solve for a sub 1. So starting out, I would probably just take the 28 and divide it by 2, which would give me that 2982 equals 14 times a sub 1 plus 228. And then we can divide by 14, move that away. So 2982, hang on. Let's see if I can do that. Okay, so if we do 2982 divided by 14, we get 213. 213 equals a sub 1 plus 228, so then we just subtract, and we get that a sub 1 equals negative 15. Okay, we still need to find D. Okay, so we've got to go back and fill in this equation again and solve for D. Okay, so we're going to use this. I think I'll just leave it there because I'm going to need it again here in a minute. So what do we know? Do we have a sub n? Yes. This is 228. Do we have a sub 1? Yes. We just found that. It is negative 15. Do we know n? We do. It's 28. And we don't know d. So we just have to solve this. So negative 15 plus 27d is 228. Okay. So we've got to add, add the 15. We get 228, 238, 232 equals 27d. Then we'll divide, and we get that d equals 232 minus 27 is 20. Wait a minute. Crazy Mrs. Bruce. 232 divided by 27. What did I do wrong? Oh boy. I can't add. This is 243. Then, okay. Then we can do 243 divided by 27. And we get that the common difference here is 9. So that allows us now, we have a sub 1 and we have d. So we start with a sub 1 is negative 15. The question up here, reminder, find the first 3 terms of the arithmetic series. So we start with 15, we add 9 and we get negative 6. We add 9 and we get 3. So that's your final answer, but remember, and I need to see all your work. So make sure you're showing me finding your a sub 1 and finding your d, not just the 3 numbers. Okay, so now we get to talk about the arithmetic series. So this notation, you will normally see the 16 will be on top, the k will be on the bottom. So what does this tell us? We have to use, let's see if I can, there we go. So we have to find the sum. We need to know n. We need to know a sub 1. And we need to know a sub n. And we can use the summation notation to find that. How you find n is we will take the n number on top. So in this case, so let's do it this way. Let's say n, which is the top number. I'm going to use a bracket here so it looks clearer. Okay, n, which is the top number. So we're going to have 16 terms, but you're going to start at 5 instead of starting at 1. So we're going to take that number and we're going to subtract the k. But then when you're trying to find how many of something is happening, hopefully you've noticed by now that, like, if I need to find a certain number of things and I didn't know how many terms are there between 3 and 6, and I need to include that 3 and include the 6. So 3, 4, 5, 6, if you count, that's 4 things. But if you just take 6 minus 3, there's only 3 there. So we have to add 1 back to get a count of how many items are actually in the sum. So you'll take the top number minus the bottom number and add 1. That's the number of terms in your sequence. So in this case, we're going to say that n equals 16 minus 5 plus 1, or 16 minus 5 is 11. We're going to use 12 for n. Okay, I might even do this. Let's just say that n equals 12. Okay, the a sub 1, your first number, is what happens when you plug in k. That's the first number of our sequence. So a sub 1 will be, and we're plugging these into the function, so it's 2 times 5 plus 6, or 16. A sub n is when you plug in the top top. We'll call it the top because it's not truly Rn. Okay, so a sub n happens to be, hang on, I want this up here. I want to make this clearly just 16. Okay, so a sub n, we plug 16 into our function, 2 times 16 plus 6. So a sub n will be 32, that will be 38. So we can find the sum. If I have a sub n, I have a sub 1, and I have n, we can come back up here and find the summation a sub 1, a sub n, and n. I can use this nice little equation once I've interpreted it to find the sum. So we know that n is 12, maybe. N is 12. I know that this is 12, and I know that a sub 1, because we interpreted this summation notation, a sub 1 is 16, a sub n is 38, and I can figure all this out. So we get 12 times 16 plus 38, that's 40, 54 over 2, which is 12 times 25, 26, 27, which is 324. So that's your solution there. The big part of this is just knowing how do you find this stuff. We have to use these definitions to come up with the n, the a sub 1, and the a sub n. Okay. So thankfully this last bit is a little bit easier compared to all of that stuff that we just did. Write an equation that represents the nth term of the arithmetic sequence in which the 100th term is 245 and the common difference is 3. So mainly here you're just trying to interpret these words into what we need. We're coming up with an equation for the nth term. So that is only asking you, we're not talking about a summation here. We're talking about an equation with a sub n. So we're looking for this. So we need to know, we don't care about a sub n. We do have a sub n, but we need a sub 1, we need n, and we need d. So do we know any of those things? Reread the problem and decide. So very clearly the last thing they tell you is that the difference is 13. That's easy. Okay. We know n when, we know what happens when n is 100. So we're going to say we know that n is 100. When this happens, I actually know more information. Let's see. So I lied a little to you. Let's put this over here. The only things that you need to solve this problem are a sub 1 and d. However, we don't know what a sub 1 is. So we've got to use more information to get there. We do know when n is 100, a sub n is 245. So we can use this equation to solve for a sub 1. Okay, so let's fill this in. We do know a sub n is 245 when a sub 1 is something, n is 100, and the common difference is 13. So we can use this to find a sub 1. We have all that information, then we'll plug in a sub 1 and come up with our equation. Alright, so if we simplify this part of it, this just becomes a sub 1 plus 99 times 13. So we get that 245 equals a sub 1 plus 1287. We'll have to subtract, and we'll get that negative 1042 equals a sub 1. So that will come up here. Now we do know this is negative 1042. And we can take that information to write our equation a sub n, because we know that a sub 1 from above is negative 1042 and d is 13. So that is actually your final answer, because what did they ask us for? They asked us for the equation that represents the nth term, so something a sub n. This part was able to tell us our a sub 1, and the difference is 13. So we were looking for this piece. We didn't know a sub 1. Our equation here, and usually, let me take that back. I would accept this in most cases. However, I forgot we defined it earlier. We do want linear equation version, so let's do that. So this becomes, instead, this becomes 13n minus 13, or let's see, 13n, if we put 1042 and 13 together, that is 1055. That's what we want as our final answer. Okay, so there's your mind-blowing lesson for this week. If you have any questions, email me. If everybody seems to have a similar question, I may toss the homework problem out there on a video like I did for the section 10.1 stuff. But now you can do the rest of those homework problems, and you should go ahead and start working on those. I want the homework to be turned in by the end of the day tomorrow, and then tomorrow I'm just going to ask you to work on worksheet 10.2. So right now, today and tomorrow, we're working on homework problems 10.2, worksheet 10.2. I haven't quite decided with what we're doing with Friday yet. We'll probably start half of the notes for 10.3, but I may make it a quiz day, like an online Google quiz over 10.1 and 10.2. So just FYI, that could be happening. So email me if you have any questions, and we will be working together real soon. Bye, guys.